Okay, so let's talk decimals for the GMAT. Well, look at this question, and if you can't do it within a minute, then this video is for you. In fact, I would argue that many people can do this with a bit of practice in a much shorter time frame than that. Now, what are we going to cover in this video? Well, we're going to cover everything from like what is a decimal to how to round things up, when do we use decimals in the GMAT, and what this strange notation is at the top here, if you're wondering what that is. If you want to skip to the end of the video to see the solution, feel free to do so. If you want to understand the different concepts that we're going to be using for solving this question, then stick around throughout the video, and in any case, let's jump right in. So first of all, what is a decimal, and what's the difference between a decimal and a digit, which some people sometimes wonder. So starting with a digit, well, a digit is just a single number. Okay, so it's one symbol. So it's, for example, 0 is a digit, 1 is a digit, 2 is a digit, all the way up to 9. And for example, the number 375 is made up of 3 digits, 3, 7, and 5. Okay? A decimal is something a bit different. So a decimal is, for example, 3.75, and it is a number that contains a whole part. So in this case, the 3. So 3 would be a round number on its own. And a fractional part, which in this case is the 0.75 bit. Okay. We could split this number, if we wanted to, into that 3, which is the whole part, plus the fractional bit, which is 0.75, or we could write that as 75 divided by 100. And if we want, we could split that even more. We could split the 7 part of it, which is 0.7, and that we could write as 7 over 10. And the 0.05, that is 5 over 100. Now, why do we need decimal numbers? Well, I mean, let's take this pen, for example, which you may or not be able to see with the background. But this pen is roughly 6 centimeters long. Now, if I wanted to precisely measure it, I can't just use 6 centimeters or 7 centimeters. I want to be a little more precise than that. So in this case, maybe I would say it's 6.26 centimeters. Okay, so it's just to express a value that is in between two whole numbers. So you may be thinking, okay, so a decimal is anything that's not a whole number. Well, that's actually not quite true, because not every decimal is a whole number, but actually every whole number can be expressed as a decimal. For example, 5, which is a whole number, we can also express it as 5.0 or 5.00. We're not changing the value of this number. We're just adding some zeros after the dots. It's just another way of writing it, which in some conditions we may want to do it that way. The key thing to remember is that actually whole numbers are also part of the decimal category. So now that we know the difference between a decimal and a digit, let's talk about the different names of the digits within a decimal. So here, Panda has created this little animation to explain things a bit better than I would. So let's take the number 123.456. Now, if we look at the digits in front of the dot, so to the left of the dot, or another way of saying that is the ones part of the whole number, well, they all end in S. Okay, so this is the hundreds digit, this is the tens digit, and this is the ones digit. Sometimes we call this the units digit as well. Now, to the right, all of them end in THS. So this is the tenths digit, this is the hundredths digit, this is the thousandth digit. Okay, so non-native speakers are probably struggle pronouncing this, but who cares? We don't need to pronounce anything in the GMAT, we just need to click on the right answer. Now, you may have noticed that there is no equivalent of a ones on the right-hand side. So there's no oneth, okay, or uniteth. So bear that in mind. Don't make the mistake. We start directly with the 10, so tenths digit on the right. So let's see an example now to illustrate this. Let's take, this one is fine. Let me move my head out of the way. So here we have a number, a decimal number, which is 3,725.48. So first of all, those of you who are from continental Europe or any country that uses the comma as the way of expressing a decimal, do not get confused. The comma in the USA and in the UK is to separate every 3 digits. So when we have, in this case, 3,725, we have 4 digits, we put a comma just in front of the 7. But the dot is for expressing the separation between the whole part and the fractional part. So do not get confused between the two. So in this case, the 3 is the thousands place. Okay, so it ends in S and there's no TH. All right, and that's because it is on the left, so in the whole part, and it is in the, so this would be the ones, this would be the tens, this would be the hundreds, and this would be the thousands. Okay, and so 7 is the hundreds, like I said, 2 is the tens, 5 is the ones, and now to the right, the 4 is in the tenths place. So remember, we jump the oneth, there's no oneth, or uniteth with a TH, we jump directly to tenths. Okay, and then the 8 is in the hundredths place. Again, difficult to pronounce, but we don't care about that for the GMAT. So now on to the topic that you've all been waiting for, your favorite, the long division. Now, I know a lot of you probably hated this at school and probably have bad memories of it. The good news is that 9 times out of 10, when you think that you need to use a long division in the GMAT, actually you don't need to use it. In most cases, we're going to try and simplify the calculation, or maybe we're going to approximate. But there are a few cases where you actually have to make the long division, and that's why we need to revise it. So let's have a look at a little animation to explain. So let's say that we're dividing 126 by 3. So most of you would have seen something similar to this at school. Now, depending on where you studied, your teacher, your country, etc., you may base things a little bit differently, but it's pretty much the same thing, just in different locations. So one way of laying this out is you write the 126 below this horizontal bar, and then you write the 3 on the left, and you separate the 2 with a vertical bar like this. Okay, and then we're going to follow a step-by-step method, which we're going to recap at the end. But the first thing we want to do is we take the 3 and we try and divide the first digit in this number here. So in this case, 1, we try to divide it by 3. Okay, now 3 does not go into 1, right? Or 3 does not divide 1. So in that case, it goes 0 times. It's too small. We're going to skip this step. So the next thing we do is we move on to the second digit. Okay, so now we've got 1 and a 2, which makes up 12. We think, does 3 divide 12? Yes, it does. Okay, and it goes 4 times. So the next thing we're going to do is we're going to multiply that 4 by 3 to get 12. Okay, then we're going to subtract, and so we're going to subtract that 12 from this 12 here, and we're left with 0. Okay, so it's a bit of a coincidence that we're left with 0 here. Sometimes there's a remainder, in fact often there is, and in that case that remainder would be here. But notice that the 4, so it goes 4 times, we've written the 4 above here, and we've put it above the 2, right? We haven't put it above the 1 because that would have been a 0. That's the step we tried before. And now, so this 4 goes 3 times into 12, so we put it above the 2. Now, the next step is to bring down the 6, right? And then we start again. So we try and check how many times does 3 go into 6, and it goes 2 times. So in this case, we multiply 2 times 3 to get 6. And again, the remainder is 0. And at this point, we've finished the whole long division, and we're left with 42. So the 2 coming from the 2 times 3 that goes into 6. So the result is 126 divided by 3 is 42. Now, that was quite a simple long division, and we'll see other ways of doing this without having to go through this whole process. Find or try to remember the way you lay things out at school. It's probably best to just stick to that method, or if you can't remember at all, copy this one. So the cycle that we've used here to work this out is called the divide, multiply, subtract, bring down, and repeat cycle, or sometimes called the algorithm. You may know it in different names. You also may know different layouts to this, as I mentioned earlier. So either copy this way or try to remember the way you did it at school, but practice it a few times because it does pop up every now and then in the GMAT. But as I said before, in most cases, there are ways of avoiding it, and actually it's better to avoid it rather than do it. Now, let's talk about what happens when we divide or multiply decimals by 10 or other powers of 10, so 100, 1,000, etc. Let's look at this little animation. We're going to look at 2 different examples. So in one case where we're multiplying by a power of 10, and another example when we're dividing by a power of 10. So let's start with 4.67 that we're multiplying by 100. Now, the result of that is 467. How have we gone from one to the other? Well, I mean, we could use a calculator, but in the GMAT in Quant, we can't use that. So the simplest way to go from one to the other is actually just to move the decimal point along by 2 steps. So it was between the 4 and the 6 here. And then afterwards, well, 467 technically does not have a decimal point, but we could write 467.0. It would be exactly the same thing. So implicitly, the decimal point is here after the 7. And you've noticed that it's gone 2 steps along to the right. Okay? And it just happens that in this 100, we have 2 zeros. So when we're multiplying by a power of 10, we count the number of zeros and we move the decimal to the right by that number of zeros. For division, it's the same thing, but to the left. So in this case, we're starting with 56.8. We're dividing by 1,000. So in this case, we're dividing, so we have to go to the left. And we have 3 zeros in 1,000, so we have to move the decimal point 3 points to the left. Now, it starts here between the 6 and the 8. One step would be here, 2 steps would be here, but then at this point, we're already at the end of the number. So we have to add another 0 before we put the dot here. And we end up with 0.0568. Sometimes we need to round decimal numbers, and by that we mean approximate or find a number that's close, which is typically a bit more simple to deal with. So let's take an example to illustrate. So let's have a look at the number on the left here, 5.678. Now, we already know that that number is somewhere between 5 and 6. So actually, if we were to round this number, we could round it down to 5 or round it up to 6. Right? So 5 and 6 are both close numbers that are simpler to deal with. And in that case, what we're doing is we're stopping the number at the nearest round number or integer. But sometimes we want to be a little bit more precise than that. So rather than stopping at the 5 or the 6 if we're rounding up, well, maybe we want to stop at the first digit after the dot or beyond that. Depends a little bit on the exam question or the application that we're doing. So here, what they're asking for is to round to the nearest tenth. We have a separate lesson on the names of the different digits, and I'd encourage you to review that if needed. As a recap, you've got the schematic at the top here. So remember that anything to the right will end in TH or THS. And anything to the left ends in just S. Okay, so in this case, we're looking for the nearest tenth. That's going to be to the right, and it's going to be the first one after the dot. So the first thing we want to do is to identify the digit that we're rounding. Right? So in this case, we're looking for the nearest tenth. So we identify the 6, which is the first one to the right. Then what we want to do is to look at the following digit. And why do we do that? Well, you'll see that very shortly. So we look at the 7 in this case, and we check whether that digit is 5 or above, or whether it's below 5. And why are we doing that? Because we want to decide whether we're closer to the top or the bottom of this number range. So if we're 5 or above, we're going to round up. And if we're 4 or below, we're going to round down. In this case, 7 is higher than 5. So we're going to round up. And in that case, we're going to cut the number at the 10th, but we're not going to have 5.6 because that would be rounding down. We're going to round up to 5.7. Let's see another example. So let's say that we have 12.8341, right? It's getting a bit complicated. In this case, we want to round to the nearest hundredth, right? So that's going to be the second one to the right, which is this 3. So remember the process, once we've identified that, we look at the following one. So in that case, it's going to be the 4. And we check whether that is below 5, 4 below or 5 and above, right? Remember, if it's 5, we should go upwards. Okay, but in this case, it's below, and so therefore we round down. And in that case, what we do is we just cut the number after the 3, and we end up with 12.83. So this number is an approximation of this horrible number up here. We could make it even more approximate, so we could round down to 12.8. We could round down to 12. How much we should approximate depends very much on the application, and in particular, what the question is asking for. Next concept is what's called the scientific notation. So you're probably wondering, well, why do I need to know that? I'm not trying to be a scientist. I'm trying to take the GMAT and maybe go to business school afterwards. What's the point? And you'd probably be right. I mean, to be honest, most people do not care about the scientific notation, and you don't need to know that it's called that for the GMAT, but you will at some point encounter it, most likely. So even if we don't care about what it's called, it's a useful concept to see at some point. So maybe let's just illustrate this with an example. Let's say we're talking about a big number, such as 5,280,000. Well, often when we're dealing with big numbers and we're doing calculations on them, it's kind of annoying to like write all the zeros behind. This number is, I guess it's a medium-sized number. You could make it even bigger, right? You could speak in terms of billions or trillions. And typically, well, there's two ways of dealing with that. Either you change the unit, right? So you could write 7 and then billion for lots of zeros behind. Or the other way of doing it is you express the number of zeros as powers of 10. So what does that mean? Well, this 5,280,000, you can write that as 5.28 times 1 million. Okay? And this a million, well, that is 10 times 10 times 10 times 10 times 10 times 10. So 10 to the power of 6. And sometimes in GMAT questions, they throw you numbers in this format. So this is what's called the scientific notation. You can have it, in this case it's for big numbers, so where the exponent or the power of the 10 is positive. But you can also have some examples where it's negative. So that's for talking about very small numbers. I think I've got one of those examples here. Yes. So in this case, it's 0.000072. Right, so here you could probably imagine scientists, I don't know, measuring the size of atoms. And if they were to write and speak like this all the time, I mean, they would spend all day saying 0.000, etc. So to make their life easier, what they do is they write it as 7.2 times, and then they write a power of 10, which in this case is 10 to the power of minus 5. Okay, so let's see how we solve that question we had on decimals. So the first thing we need to do is to deal with this notation here at the top, right? So if you followed through the videos, you would have seen that this is what's called the scientific notation. Again, you do not need to know that for the GMAT, but you do need to understand what this means and what it's equivalent to. So when you have a number like that, which you multiply by a power of 10, and in particular 10 to the power of minus 1, effectively what you're doing is you're multiplying by 1 over 10, or multiplying by 0.1. All of those are the same thing as taking the decimal point and moving it one step to the left, right? Because we're effectively dividing by 10 here. And given that there's nothing in front of the 1, right, we need to put a 0 afterwards. So we get 0.18766. Okay? So that's the first step. And then afterwards, we need to count 100 of those. So we're going to multiply them by 100. And remember that when we're dividing or multiplying by powers of 10, if you haven't seen that video. So remember that we're essentially moving the decimal again along a certain amount of places, and in this case we're moving it to the right. And how many spots do we move it to the right? In this case it's 2 because we have 2 zeros. So we go from 0.18 and then something to 18.766. So we've moved the decimal spot 1 step and then 2 steps, so we arrive behind the 8, but then we drop the 0 at the beginning because 0.18 is the same as 18. Now the last step is to round this number to the nearest hundredth. Okay, so remember, first of all, what is the 100th digit? So it finishes with a TH, it's going to be after the decimal point, so to the right, and it's going to be the second one. So it's going to be the 6 here. But for rounding up, we have to go one step beyond. So you have to look at this one and see if it's closer to 0 or to 10. And in this case, 6 is closer to 10, so we round up. And what we do is we replace that 66 by just a 7. So we get 18.77, and that is our final answer, and that's B. So for those who are a little bit more comfortable with this, you can probably see that you can go a lot quicker here. This is not a official GMAT question. It is kind of an example of what a question could like if it was just focused on these concepts we've seen today on decimals. But there's a number of ways of going quicker here. You can combine these multiplications together in one step, go a bit quicker, and you can also, just looking at this, you can just try and round up looking at the answers, right? But the purpose here is not to illustrate how you can do this as fast as possible, but it's more to illustrate the different concepts that we've seen in this lesson today.